Break glass access is the last resort path when normal identity controls fail. It is not designed for convenience. It is designed for safe recovery, tightly restricted, approved, monitored, and audited access that helps restore critical services without creating unmanaged privileged risk. We've already built the foundation: identity, privileged accounts, attack paths, and modern access control principles. Now we focus on break glass access, the safety mechanism for failure scenarios. It connects emergency continuity with governance and prepares us for Module 2, where we move into PAM architecture and vault controls. A break glass account provides an emergency way back into critical systems when normal admin access is unavailable. If SSO, MFA, PAM, or approval workflows are down or blocking recovery, this account can restore control with very high privileges. Because it is so powerful, it should never be used for routine work. It must be intentionally designed, tightly protected, tested, monitored, and reviewed as a true last resort tool. Normal administration can fail in several ways. The identity provider or SSO may be down, preventing admins from signing in. MFA may be unavailable, blocking even valid privileged users. The PAM vault or session broker may fail, making credentials unreachable. During an active incident, responders may also need direct access immediately. Break glass accounts exist for these rare, high-impact moments. Standard privileged access is the normal operating model: narrow, approved, time-bound, strongly authenticated, and fully monitored. Break glass access is different. It exists when those normal paths are unavailable or too slow for a high-impact incident. Because emergency accounts often carry broad standing privileges, they are inherently riskier. That is why they must be rare, visible, and reviewed after every use. The objective is controlled survivability, so teams can protect people, systems, and business operations when failure conditions appear. Break glass access is not one account in one place. It is a controlled set of last resort identities mapped to the systems that keep the organization running. In cloud identity, that may be a tenant or global administrator. In directory services, it may be a domain admin or forest recovery account. In a PAM platform, it may be the administrator needed to recover the vault itself. For critical systems, it may be local root, local administrator, database owner, or application recovery access. The key principle is coverage. Every control plane needs a protected path back in when normal access fails. Think of a break glass account as emergency equipment. It must work immediately in a crisis, but it cannot be easy for anyone to grab. That tension defines the risk model. If it is too accessible, attackers can use it to bypass MFA, PAM, or conditional access and move straight to critical systems. If it is too restricted, your team may be locked out when recovery matters most. The goal is controlled availability, strong protection, clear documentation, regular inspection, and unmistakable logging whenever the account is used. A good emergency access design is hard to abuse, but usable when normal controls are down. Start with strong, unique credentials that have high entropy and are never reused. Then make sure the access path is independent. If primary SSO the directory or a cloud MFA service is part of the outage, the break glass account cannot depend on it. Prefer phishing-resistant options such as FIDO2 keys or certificates when they can operate during the incident. Where appropriate, maintain at least 2 validated emergency accounts so recovery does not depend on a single point of failure. Credential storage creates its own balance. Recovery material must be unreachable to attackers, but reachable during a real outage or lockout. Store it outside normal systems, such as in sealed envelopes, safes, hardware modules, or independent vaults. Retrieval should never be casual. Define who can request access, what incident conditions must be confirmed, and whether 2 custodians are required. After use, record what happened, who approved it, and when it was accessed. Then rotate the credentials so emergency access does not become a permanent backdoor. The operating goal remains controlled availability, not convenience. A break glass account should be surrounded by policy, technical controls, monitoring, and audit review, so normal administrators are discouraged from using it for daily work. Keep it out of shared scripts, automation, and routine workflows, because those create exposure and dependency. At the same time, Be careful with conditional access. If the identity provider or MFA path is what failed, the emergency account still needs a valid route in. Restrict locations where practical, then test every control against realistic outage scenarios. Break glass activity should never be quiet. The moment an emergency account signs in, retrieves credentials, changes configuration, grants privilege, or creates a token, that event should flow into centralized monitoring. Ideally, logs go to a SIM that is independent of the system being rescued, so an attacker cannot easily erase the evidence. Detection should cover both successes and failures, because repeated failed attempts may be the first warning. Real-time alerts should route to the right owners: SOC, IAM, infrastructure, and incident response, with clear escalation expectations. Reliability comes from testing before an emergency. Schedule validation on a recurring cadence, such as quarterly or semi-annually, and make the test realistic. Simulate identity provider outages, MFA failures, PAM downtime, and urgent incident response access. Then verify the essentials. Credentials still work, procedures match reality, alerts fire, and logs are captured. The most important output is action. Record the results, identify gaps, assign owners, and track remediation. Readiness is not a document. It is a tested capability. When break glass access is used, it should feel like an incident process, not a shortcut. Start with a documented trigger: an outage, lockout, compromise, or recovery need. Notify the right stakeholders or obtain approval when time allows. Then follow the runbook exactly as written. Retrieve the credential, authenticate, perform only permitted recovery actions, and communicate status. Monitoring and documentation should run throughout the event. Capture who decided what changed, and when. Closure is not complete until access is revoked and the record supports accountability. After emergency access has done its job, the priority shifts from restoration to closure. Rotate or reset the emergency credential right away, so it cannot become a standing backdoor. Revoke any temporary permissions, tokens, sessions, or alternate access paths created during the response. Review logs, session recordings, configuration changes, and command history to confirm what happened. Finally, document findings through an audit or post-incident review and update the runbook. This closes residual risk and turns the emergency into a governance improvement. Break glass accounts are resilience tools, but they are also high-risk privileged assets. They must be rare, ready, monitored, and recoverable. Strong authentication, restricted use, secure storage, alerting, logging, and testing make the design defensible. Procedures, approvals, rotation, and audit review make it operationally safe. Next, we build on this foundation with PAM architecture and credential vaulting.